question is, what do you mean by activity and selectivity of catalysts? First of all, we will discuss about the activity of catalyst. Its basic function is to increase the rate of a particular reaction, but in some cases catalyst is also used to decrease the rate of a reaction. But for a syllabus, it is enough for you to know that the activity of catalyst is to increase the rate of a particular reaction. Moving on, it depends on the strength of chemisorption to a large extent. So if the strength of the chemisorption is high, then the rate, it will highly increase the rate of a particular reaction. If the strength of chemisorption is very low, so it will not increase the rate of a particular reaction by a large extent. Okay, adsorption of reactant should be neither too high nor too weak. It should just be optimum so that the catalyst is staying active. Now moving on to the second point, the selectivity of catalyst is the ability to direct the reaction to give a particular product when under the same reaction condition the products are possible also. What does this statement mean? So okay, I will write here what does it mean. So suppose we have some reactant, I will denote it by R. I will make 3 arrows, 1, 2 and 3. Suppose in the first case we have C1 catalyst, in the second case we have C2 catalyst, and in the third reaction we have C3 catalyst. Okay, so if we use the catalyst C1 and the reactant R, we get the product P1. If we use the reactant R and catalyst C2, we get the product P2. And if we use the reactant R and use the catalyst C3, we get the product P3. So this entire point meant that it is a possibility that if we use different catalyst for a particular reactant, we might get different types of products. So this is an example of what I was trying to explain. So we have the reactants carbon monoxide, CO, and hydrogen, H2. So if we use the catalyst Ni, we get the product methane. Okay. Methane plus water. If we use the catalyst CuZnO Cr2O3 chromium oxide, we get the product methanol. Okay, if we use the catalyst as copper, we get the product methanol. Okay, so as you can see, the reactant remains the same and the catalyst is different, and also the product becomes different.